Hello, everybody. If everyone from the Grow Your Own team just says a quick hello, I'm Dane, and here's all the rest of the team again. Hello, everybody.
Hello.
Hi.
Hello.
Hiya.
So we've got a slight different order to doing things today. Sophie's not here, so we're going a bit off on a different direction, but still using the Arduinos and still doing coding, but we're going to try a different way around of doing it. Just to see how things can be built in different ways. Hopefully things will be relatively straightforward and you'll be able to follow all the instructions, build your real life circuit and get lights flashing in a really imaginative way that can be even more imaginative next time round. So at this moment, I think it's time to pass on to CJ, who is going to take us through the next step and stage of our coding.
Okay, thanks, Dane. Hello, everybody. It's good to see you all, sort of see you. Okay, I'm going to take you through now the physical setup of the Arduino rather than the Tinkercad, and then we're going to briefly look at the Tinkercad, so you've got something to refer to with something that you are quite familiar with. So, but first of all, I want to check that you have your equipment, have got all the equipment. We sent out an email. So I'm going to go through the list now just to double check we're all on the same page there and we've got all of the bits, components that we'll need for when I direct you through the setup. Okay, so have we got our Arduino and the USB cable? Yeah, Kathy has. Great stuff. Got some thumbs up. Yeah, if you could put a thumb up, that would be great when you have got that. Yeah, nice. Caroline, Reese. Cool. I'll go through the list then, and maybe if you haven't, we'll come to that when you haven't. So we need also the breadboard, the LEDs. We're going to use 2 LEDs today because that's, I think, all we'll have time for, but the setup is exactly the same. So we'll go through 2 setups of LEDs this time, and you can add more in your own time if you wish. Jumper wires. So I've got 5 black wires for ground. So we're going to use black wires for our ground. Great. Yeah. And then we're going to have a handful of different colored other wires as well, like with this, the same but different colored. So exactly the same as the ground wires, but just not black, multicolored, different colors. And then the resistors. So we need 1K ohm resistor, if you're able to locate those, and 220 ohms. And finally, a button. Okay, so once you've got all of those collected together, if you pop a thumbs up, great. I'll just give you a few moments there. Just that. Oh, and also if you could just open up the Arduino on your computer as well, the software. So we'll be ready when I send over the code, the text. Okay, got. Has everybody got all their stuff? Did I get a thumbs up? Didn't see a few from Lewis or Rudra. I'm not sure if you've got the bit. Yeah, Lewis has. Great, thank you. Dave has. Just actually Rudra, Susanna, and Richard. Richard, yeah, great. Reese, yeah, nice. And just Rudra now. I think that if we can, maybe if I can begin, and then perhaps if if in the chat, pop in the chat if you're not ready or need me to slow down. Okay, so let's collect all. So we've got all of our equipment. We're going to start with getting the breadboard. Just place it down and get your button hand to hand. And we're going to place, so this is interesting to describe, but we've got the middle ridge. There's like a gap in the middle. We're going to effectively place the button over those two, over that gap. And the holes, so the holes are E24, F24, E26 and F26. So two ends of the button are going into E24 and E26.
So for those of you who might not have spotted this, you'll see that there are numbers and letters on your breadboard.
Oh yeah, they're very small.
They're very small, and so it goes A, B, C, D, E, and then there's a heavy kind of gap between row E and row F, and then it goes F, G, H, I, J. So we'll be using those letters around one side of the board, and then on the other side of the board, the numbers go all the way from 1 to 30. And then either side of those lettered rows, there's the positive and the negative channels too. So when we're kind of saying these numbers, you can almost think of this as a coordinate, a bit like battleships and cruisers, you know? So you can put the, as Kathy's showing you on her video screen there.
Yeah, great. Exactly. Across the middle, yeah? Yeah, thumbs up again would be great. Great, great, great. Just the last few people. If you have any questions, pop it into the chat. Or if I'm going too fast, just let me know. Okay, so now let's grab our 1K ohm resistor and place one end into D24 of your breadboard. That's D for dog, 24. And the other end into D22. D for doggy, 22. It is a bit like Battleship, that is. Okay. What do we need to place in that? Ah, Lewis, yes, you're exactly as Emily said, your 1K ohm resistor. That's the 1000 ohm resistor. Brilliant. Okay, and let's now take our first black ground wire. Oh, lost somebody. First black ground wire and put one end into C22. And the other end is going to go into anywhere on the, so it's on here is the left side of the minus line, this line here. So any of those holes in there, you can place the other end of that black ground wire. Close by to row 22 though, if possible. You can see the row, the number 22, if you put it close by to there, just so it's lined up nicely, as much as possible. Exactly, yeah. That's it. I'll just get Rachel in. That's exactly as Dane's done, yeah. That's great. You don't have a 1K resistor, but you do have a 2K resistor. Yes, that should be fine. Okay, so I'm gonna go on. So get our next black ground wire and put one end into the same blue minus side that we've just been working on, close to row 24, but in that same line. It doesn't have to be perfect, but just close to row 24 of that same blue minus line that we've just used. And we're going to put the other end, and we're going to put the other end into on the Arduino board, so into the digital GND pin. That's the ground pin on our Arduino boards, capital GND. So that's okay, great. Some thumbs up. Okay, so now we get a colored wire of our choice, any color. And we put one end into G26, G for golf, 26. on the breadboard. We're back onto the breadboard now. So G26, one end, and then going on to our Arduino board, we need to find the pin. It's very small, but the number 3 on the digital side. So it says very small on both sides. One side is usually saying analog AO, and the other side's, depending on what board you have, it says digital side, and we need number 3. To look very closely, it's tiny. But number 3. Yeah, Dragonfly says yes. That's a good sign. Yeah, Dane's showing it there close up.
And you can see it's written on the board itself and also on the black thing on both sides of the black thing that sticks up. There are the numbers on the side. So if it's easier to read those, you can read those too.
Yeah, thank you. Okay, so we've got that wire and that wire connected up. Okay, so now let's get one of our LEDs. Any color, a color of your choice. Okay, and we're going to place the longer end, that's the positive end, into letter A and number 28 of the breadboard, A28. And the shorter end, the negative end, is going to go into A29. And now we're going to take our first 220 ohm resistor. So they're different colors. So I think as long as, it should say on your pack. So 220 ohm. Yeah, some of the colors, sometimes they're blue. Yeah, that's it. Sometimes red, a combination of reds. Okay, and we're going to put one end into B for Bertie, 28. And the other end into C for cat, 28. So one end in B28 and the other end in C28. Thanks, Stuart. And now let's get another coloured wire of your choice again. And place one end into E28. E for echo 28. Echo, echo, echo. And the other end into get back our Arduino board, and we're going to put into pin 10. So the digital side, number 10. This board. Just checking. That's good. Okay. So we've got that in E28 and pin 10. Now we're going to get another ground wire, a black ground wire. And we're going to place one end into C29, C for cat, 29. And we're going to place the other end of that wire into the opposite side. So the other side of on the blue minus on the breadboard, the opposite side to what we used the first time we placed it into that minus line. So the other end. So one end into C29 and then the other end into the other side of the breadboard minus sign. If you can put it close to row 29 to keep it relatively in line. Okay, now we're going to get another ground black wire. And we're going to pop one into, okay, so the bottom of the right blue minus side. So the same side that you were just on, just put it at the end. It can be either side, it can be at 1 or at 30, as long as it's on towards the end. And then we're going to put the other end of this into our second GND pin on the Arduino board. There are two next to each other. So place it next to the one that you've already using on the board. It's very small, but they are right next to each other. Another GND pin. That's your ground pin. Okay, on the power, yeah, the either one, but you can place it next to the one that you have just done, so it can go on either GND pin, Dave. As long as you've got two GND pins hooked up so far, we're on the right track of the Arduino. Okay. Next up, we're going to get another LED, our other LED, and we're going to put the positive end, the long end, into A17, A for apple, 17, and the shorter end, that's the negative end, into A19. Please, can I see some? Okay, Lewis, yes, let me, perhaps I could share. Yeah, A17 and 18, A19, yeah. I'm just wondering, could Kathy or Dane hold up there, because mine's all connected to many wires. Could you hold up your...
This is what I've got.
just put it close up so Lewis can just check, because I think they may have missed a few steps. But Emily said you can send the full instructions and with an image. It is hard to sort of see, but if Lewis, do you have the email that we sent? I think there was a couple of pictures, or maybe pop through the instructions just to see where you've missed. Yeah. Okay, so where did we get to? We've got to A17. We've got one long end into A17 and the short end into A19, yeah, of the LED. So now we're going to get our final 220 ohm resistor. And we're going to place one end into B for Bertie, 17, and C for cat, 17. And now if we grab our final colored wire of our choice, and we're going to place one end into E17, E for echo, 17, and then the other end is going to go into pin 11 on the Arduino board. So right next to the other number 10 that we put in. And now we're going to grab our final ground wire, a black one, and place one end into C for cat, 19, C19, and we're going to place the other end into, again, our minus strip on the right hand side of the breadboard, or the opposite side of the breadboard, nearby to row 19. Just check the chat.
Close to row A.
Close to row A, row 19. Yeah. I'm just going to share my screen now, just to check that you've got it set up. Okay, so if I share my screen, there's a couple of images you might be able to look closer at. So bear with sharing my screen. Just got to grab. I mean, it should look something like this. A little bit difficult to see always. Whenever you take a photograph of your board is always hard, but let's hope for the best. And I'm going to give you the code now and see if our LEDs light up. And what we're going to do is we're using this button here. This is our controller, so it's going to control LEDs coming on and off with a delay between each one. And the more LEDs you have, the kind of nicer the effect looks, because they all kind of come on in succession and then they go off in succession with the control of the button. Okay, so I'm gonna stop sharing if that's okay. I'm going, oh, the code. So we're going to get that GitHub link. I'm going to send, or Sarah is going to send you the, I think, the GitHub link into the chat. And if you click on there, that's the code that I've created in my Arduino. That's the demo code in order to make this function of the button work to light up the LEDs. So if you click on that, and when you've clicked on it, it will come up. If you copy and paste the entirety of that text, including make sure you include the final close bracket at the end, the curly close bracket. That's absolutely essential because that closes the statement before we're able to publish. So copy and paste that, if you haven't already, get the Arduino software app open on your computer. Oh, Dane, you're on mute.
Sorry, I was just going to say, so once you've managed to go to the GitHub link, which is just a web page for storing information, it will start off with // constant won't change, full stop. And then it's got a whole string of code all the way down to a little curly bracket that's alone by itself on the very last line after serial.println in brackets, button, state, close brackets, semicolon, and then there's that little curly bracket at the end. So copy all of that all the way through to the end and paste that into Tinkercad. Well, not Tinkercad. The
Arduino.
Arduino.
I'll just go through something. Once you've copy and paste that into a new sketch, you can click File, New, and it should bring you up a blank. It might say void setup and void loop. If you delete everything, so it's completely blank, so it'll look. Thanks, Sarah. So I'll just share and I'll show you what it looks like. It needs to be completely blank, like this. So when you go to new, you might still see in there the touch setup, void setup and void loop, but it needs to be completely blank like this. So just delete any text that's in there already. And when just to check that we've got our board set up, so is your USB plugged in now to your computer? If it's not, plug the USB into your computer, into the USB on the side, and then into the opening on the Arduino board, the socket. So you have that connected up. Okay, so before we copy and paste the text from GitHub here, or if you have already, that's fine. I just want to check that everybody's, if you go to tools here, that I'm doing, I think you can see my screen. We scroll down to port, here, just below board. So port, it's got an arrow that goes to the right there. So tools, port, and then we want to just check that the board, our board is ticked, and it's usually got in brackets. For you to be able to distinguish between these, it's usually got in brackets Arduino Uno or Arduino R3, whichever one you're using. So tools, port, yeah. Arduino R3 or Arduino Uno is ticked. So once all of that is ticked, you can copy and paste that text from the link on GitHub that Sarah posted in the chat. Copy and paste that into here. So I'm going to also do that. So I'm copying from the bottom right with that last bracket is all the way to the top. Copy. And I'm going to paste it into my blank sketch, my new blank sketch here. And as you can see, after serial.print line button state, we've got the close bracket here. That needs to be there just to reiterate that. Okay, we're getting close to crunch time. Like, let's hope this works. Okay, so if we're all there, can I get a, let me just check now. I'm going to stop sharing. Hang on, I won't stop sharing yet, actually. I'm just going to check that maybe a thumbs up that we're all sort of there. And if not, pop into the chat. Notice there's a few. Okay, some, yeah. I'm assuming we can't get to the Arduino screen where it says. Ah, okay. Caroline and Lucy. So do you have this software on your computer, the Arduino software, this app? This one. It should be on your computer, yeah? And you've opened it up. Okay, so if you go to File and then New, should do that.
So it might.
That's fine. That's just, yeah, that's what I've called their code. So don't worry about that. The title that I've got there, touch button. Sketch Mayo 5, that's what it says on mine for a new one. That's fine. As long as you've got one of these windows pop up and it's got void setup, void loop. Yeah, then delete that though. Delete all of that out. We don't want any text in there because we've got the code already set up. And then we're going to copy and paste that code from GitHub in there. Okay. Okay, so I think we're on track.
Mm-hmm.
Okie dokie. So now let's, the moment of truth. Okay, so tick the click the tick up here. Can you see that I'm hovering over there? The tick there, and then it comes up with verify. So by pressing this, oh, that's saying to rename it. So name it of your choice. You could just say button LED, button LED. I'm gonna just save it as that for now. And we're gonna click that button, and what that click does is it compiles the sketch, so it reads it all, and then it checks for any errors. And it should say, if there's no errors, it should say at the bottom, done compiling, and then below that, there's a black bar here. And if there's no red text that says any error codes, then we're good. We know that the code is correct and it's in line with Arduino rules. So we know that that's all formatted and written correctly. Just checking the text. Your cursor is on the other. Yeah, sorry, Dave. Now that's the tick button is the verify button. Yeah. And then now we're going to upload it to the board. So directly next to the tick is the arrow, and that's the upload button. So this is going to now upload all of this code to the Arduino board so it can match our setup with the code. And this should hopefully allow us to use our button to see the LEDs light up. So click that button now.
And this is the arrow pointing right in the circle.
Directly
next to the tick.
Yeah, exactly. And then it should say done uploading when it has. And then you press your button on your breadboard, and hopefully your LEDs light up. Has anybody got success? Yeah. Dave, Stuart has. Lovely. Nice bright lights there. Wicked. Catherine has. I can't see everyone because
I unfortunately have got red writing.
Oh, you got red writing. What's it say in that red writing?
Oh dear. Programmer is not responding.
Ah, that's so it's not through the text, I don't think.
I think I've probably put something in the wrong. I put a wire in the wrong thing.
Oh, okay. Which one?
I have no idea.
Do you want to check the photo, or do you?
I'd recommend looking through the Word document, the guide.
I wouldn't worry about.
I
wouldn't worry about me. Yeah, I wouldn't.
It might just be that there's one loose thing, so make sure they're all fully in. The resistors are the ones that are really tricky because they bend. So it might just be that your resistor, for example, isn't fully in. So I just make sure they are actually in the breadboard, because the resistors I know I struggled with. So yeah, just double check the connections.
If anybody hasn't got theirs to light up, just pop it into the chat and I will cry. No. But that's good that you've got those nice bright lights. Stuart seemed to have good bright LED light up there. And Kathy does as well. Yay, really nice and bright. Great. Okay. We've still got a bit of time, don't worry. We can all of us can sort of catch up now. There's no competition. So when you press the button, the LEDs should come on one after the other with a very short delay in between each one. Specifically of 300 milliseconds in between delay. Yeah, not 3 seconds, it's 3 milliseconds, I think. Is that? Yeah, 3 seconds, sorry, 300 milliseconds is 3 seconds. Is that correct?
It would be about a third of a second.
Third of a second. I'm getting all confused now that I've seen that. Okay, your green light. So one of your LEDs comes on, but the other one doesn't. And it stays on, yeah? So when you lift your finger off the button, does it turn off? Yes, okay, that's working. It's just one of your LEDs. Just check that first check is perhaps to see that the long end is, I'm going to go back to that area. The positive end is the long end. So this needs to be in the pin. Okay, how to explain this? Which LED, what number is the LED that's not turning on? Can you see that, Lewis? Which number on the board? E. Is it for your pin 10 LED or your pin 11? That's a helpful question to ask. Are you able to share your screen and show us on here? Oh, you've written here 28 for the long. Let me check. Pin 10. So let's have a look. Yeah. Okay, you can switch the two. So switch the the LED around. So put the opposite. So put the long leg into the where the short leg is now. Just literally flip it round and see if that helps. So the long leg is going where the short leg, and the short leg is going where the long leg was. Okay.
Could it be that the LED itself isn't working? So could it be that switching out a different LED could help?
That's also definitely another way to check. Okay, if you check that, but you can hang back as well, Lewis, if you want, and we can go through it then. If it's okay with everyone, I'm going to just, since majority, I think, have got them to light up. Doesn't matter if we haven't, because we can go through with the people who haven't. But I'm going to share now my screen again, because I'm going to show you the Tinkercad setup for this physical setup that we've done. And we're not going to go through everything that we usually do when Sophie's here, usually go through the blocks together. We're not going to do that because of the timing and because we did it this way around. But I'm going to show you anyway, and I will send you this document, and you'll be able to do this as homework maybe. Shouldn't take too long because it's all there for you, but you can sort of do the learning at your own pace and kind of match it up to the physical setup. So let me share this now with you. One second, computer is being a bit slow. Okay, right, share screen. I'm going to share this with you. So this here, everybody can see, this is the Tinkercad version of our physical setup that we have in front of us. This is the Tinkercad setup, and this is what you can do at home in your homework. But as you can see, it's probably similar. I think a few differences, of course, with setup, but it's a bit more easy to see on here, perhaps, than your actual physical setup. But they're both doing the same thing. And the code here, the code Tinkercad block code is here. I'm just going to move. And basically, we're going to be using the control, or when your own time, the control block, majority, and then output, input, and math. They're the three what we're going to be using. We won't be using any notation in this case or variables. So we're just going to be using control, output, input, and math. And you don't have to do this now. Again, this is just for me to sort of visually show you, and then you can go back to this in your own time for your homework. So we've got this to set up as you've done before. I'm assuming you know kind of how to work around Tinkercad and know the different buttons, but we'll send you this as well so you can refer to it. And we've got the blocks here set up. So we've set the pin. The different pins on here, it's 12 and 11 and 10 and 9. That's because we've got a few more LEDs in here, which you can also add to your physical board if you wish. It'll be exactly the same by just adding exactly the same for your current LEDs, just adding a couple more in. But you don't have to, that's not essential. That's just if you want to explore and experiment in your own time. And it's basically the same code condensed to Tinkercad version of what we've popped in, what I pop into the chat and what you've used in your Arduino. As you can see, we've got the delays here, that it's instead of saying delay, it's a wait. So wait 1 second. Everything else is pretty much the same without all of the other text that you have seen in the Arduino. This is a very simplified version of the text that I've given you in the Arduino. So you can cross-refer to see if you can learn between the two if you wish as well to experiment. But yes, it's a much more simplified, easier code here to read. Okay, so I'm going to send you that. Great. Okay, so that's basically the active part of the session completed. And I'm glad that the majority of us have managed to get our LEDs working. It doesn't matter if not, because there's always some hiccups with Arduino. It's always the same. There's never really a day when it goes perfectly. So don't worry about that. I'm going to now explain a bit, because so this session we used the button. So that's the smallest button that you've used. And for next session, we're going to do a hack, basically. So we're effectively using exactly the same setup that we've used, but instead of the button, we're going to use a hack that's going to turn the push button on the breadboard to a textile button. And that's why you've been sent the conductive tape in the post, which you should have. Kathy's showing that now. That's great. So that's going to allow us to create our textile button, and that is effectively the hack. We're going to swap the button that we've used in the breadboard with this textile, and you can be as creative as you want. You can sew the conductive tape to a glove, or you can literally place it on your hand, like stick it on your hand, and then the other end can go to the little art thing that we create. So I'm going to give you now a little demo of what I've done in the last week, of what we're kind of hoping to achieve at some point this year. It can be in your own time or over the summer or whatever, and next session we're going to develop on it, and I'm going to show you how to make this hack, how to make this textile button. So you're able to then incorporate it into a mini nature sculpture of your choice. I'll show you two examples now that I've done. I did a mini grass patch out of recycled materials, and some jellyfish as well out of recycled material. So let me just get up my video. And I'm sorry about my videoing skills are definitely not up to scratch. Very sorry about that, but you can see basically the situation of what's happened. So let me get this up. Okay, sharing my screen. So it's a little bit dark to begin with. So this is my grass patch, and I chose to do this because it's as simple as when I go out into my garden, I can't ever decide whether I should mow the lawn or not, because there's loads of dandelions and they look really beautiful, and basically it looks nice and wild and overgrown, but I'm kind of trying to decide, do I mow the lawn or do I not? And that kind of just inspired me to make a little grass patch. And I used garden wire and some recycled egg box that's green as well, and some recycled mushroom boxes that's like a plastic, and they're all green. So I'll show you this video now and stop talking and actually show you the video. Okay, so it's a bit dark here, but it should take you through it visually. You can see that's my little grass patch that I've put. That's my glove, and I'm touching the other part of so I've got the two conductive wires there. One is attached to my glove and the other is attached to a bit of paper. I actually did a handprint of paint. So you can get as creative as you want, basically. Let's show you again, just so you know. So the other half is attached there, as you can see, to crocodile clip. And I did my handprint. And then the other bit of conductive tape is attached to my glove. And I touch it down like that, and it turns on the 3 LEDs, so you can see the little grass patch lit up. And then it does it again. Okay, so that's the grass patch, and now I'll show you the jellyfish. Let's find it. Here we go. Okay. Is my screen still being shared? Yeah, I think so. Okay, jellyfish. Here's my jellyfish. So it's out of plastic bags, really simple. And then I found some blue wires just in the street in like a tip. I've just tied them to the ends, and I blew into the bag. So it gives that effect of bubble, like blown up little jellyfish. And I've got the same mechanism. So one strip is on the pan print on the paper, and the other is on my glove, and it lights up the LEDs inside the jellyfish. Yeah, so that's kind of the idea of getting in touch with nature literally. So that's what I was trying to explain in the other session. So we're literally touching. The hand can also be on your object. So you could potentially put the conductive tape, you could attach it to your little art sculpture, and then you can touch with the glove to your conductive tape on the jellyfish, for example, or whatever, or plant. And it can be a plant, it can be anything in your home. It can be something that already exists, like a plant, or it can be something that you make out of recycled materials. And it can be as simple or as complex as you wish. Another idea I thought about as well is a volcano. I think some people, perhaps at school or on after school art clubs, you may have made volcanoes that sort of erupt, but instead of this eruption, we could perhaps place an LED at the top. So a red LED, for example, that could suggest lava. So when you touch it, the red LED lights up. So you can make a little volcano out of some cardboard, a bit of paint, anything. It can be as simple as, as complex as you wish. And I can send you, sir, before the next session, we can send you some ideas written up as well for you to refer to. Okay, let me stop sharing my screen. I hope that's been useful and helpful. So it's sort of developing on from this button to a textile button. That's the idea. And to embed our LEDs into a little creative art sculpture inspired by nature. So I think that's kind of CJ. Yeah,
that's really good. It's a nice to see where we're going in the future workshops. So if, like some of you, yours hasn't worked, don't worry. This is tricky. It's a new way of doing programming. So I'm going to have a look through this Word document that's been sent around and check that I've wired my board up properly, because I've probably done something wrong there. We will be staying behind afterwards to do a bit of troubleshooting. If you're needed to do that and are able to do that, that's great. But I think if you sign up for the next June workshop, we'll explore how we can hack and extend our Arduino beyond what comes in the pack that was sent out originally, to take some found objects and how you can be creative in your own way. And CJ's got some really cool examples of how that's been done with their work. So I think, thanks so much, CJ, for this new way of doing it. Thanks to Emily and Sarah for all the troubleshooting as usual, and lots of administrative help in the background that's keeping this thing. It's trickier than it is, than it appears to be. There's a lot of planning that goes into these things, and so even when we try and get this seamless, it doesn't always work 100% of the time, and I'm an example of that not working. So that's just the way it is, and I'm not. It's okay to not have things working, because then they can be fixed. And we might go through at some point what all the kind of codes in the and what we've copied and pasted in a bit more detail another time, because sometimes when we work with Sophie and we kind of do things using the Tinkercad, it's quite clear what all the bits and pieces are doing. So we know that this one has probably felt a bit more like painting by numbers, just following the instructions. But we wanted to get through a new way of doing it quickly in the hour, which I think for most people has worked. So thanks for being involved and patient with what we're doing. So do we need anything else to say, or shall we wrap up there and go into the troubleshooting part of it? It's just approaching 6 o'clock, so people may need to go, but if you want to stay, please stay behind.
And if you have got any questions regarding any materials, questions for making your little sculpture, you can, it's possible to send an email, Dane, or is there communication?
Yeah, I think so. Emily's been sending out information. Yeah. So you've got Emily's email address.
Yeah.
And if you have any questions of found objects that you want to kind of work with, if you just want to send that through, we can sort of suggest whether or not that's a good idea. I'm sure most of the suggestions will be good ideas, though.
The majority of next session will be focusing on how to hack up, the textile button using the conductive tape.
So I think the idea is to not take apart your Arduino and breadboard between this week and next week if it's working. So that's going to form the basis. Take it apart
and put it back together again. We have faith in everyone.
So this is going to form the basis of next week's hack.
Next month, right?
So next month's hack. Sorry, next time. But yes, thanks everyone for coming.
Thank you, everybody.
Great to see everyone.